Suppose there is one simple concept has been developed based on irrational number system, that is called surds. A is a non-negative integer. N is either negative or n is any rational number. Then a to the power of 1 by n is called nth order surd. N is the degree of this. Suppose if I take n is equal to 2, we are calling it as a quadratic surd. N is equal to 3, we are calling it as a cubic surd. N is equal to 4, we are calling it as a biquadratic surd. Suppose I have a like this, root 2 as well as 3 root cube root of 2, in the same manner fifth root of 2. These are all called like surds. That implies the same number is there under the square root, but the powers are differing. Therefore, we can say that these are all called like surds. The same manner, suppose if I take like this root 3 and cube root of 2, these type of surds are called unlike surds, which the square root part is differing. Therefore, these are all called unlike surds. Now, my main interest is like this. Can we say that 2 plus root 2 whole square is a surd or an irrational number? But you should know that every surd is an irrational number. Therefore, here we can say that if you expand this one, we are going to get as a 4 plus 2 plus this we are calling it as a 4 root 2. This is nothing but 6 plus 4 root 2. Therefore, 6 plus 4 root 2 is also a surd, which I can say that which is also an irrational number, because of root 2 can be expressed in the form of 1.414. If you simplify it, again you are getting it as a decimal, either terminating or non-terminating decimals we are going to get it. Now, there is one simple concept has been developed. Suppose if I have any a plus root b is there, then there exists another surd which is a conjugate of this. We are calling it as a minus root b. That is called. Now, this is for every surd there exists a equivalent and opposite conjugate surds are existing. Now, for example, if I take like this, root a plus root b is there. If I want to find out a real integer, there is one simple term, there is one simple concept is there. That is called, for every surd there exists an equivalent and an opposite conjugate surd, which we are calling it as root a minus root b. Therefore, if I multiply this and this, we are going to get as a minus b. A minus b as an integer. In the same manner, suppose if I take like this, a to the power of 1 by 3 plus b to the power of 1 by 3 is there. But in this case, what I can say is, if root a plus root b is there, if there exists a surd of root a minus root b in such a manner that root a plus root b into root a minus root b, if it is giving it as a real number, then I can say that root a minus root b is called a rationalizing factor for root a plus root b. The same manner, for root a minus root b, root a plus root b is the rationalizing factor. In the same manner, if I take a to the power of 1 by 3 plus b to the power of 1 by 3, the rationalizing factor which I can express in the form of a to the power of 2 by 3 minus ab to the power of 1 by 3 plus b to the power of 2 by 3 is the rationalizing factor. The same manner, if I take a to the power of 1 by 3 minus b to the power of 1 by 3, if I take it, the rationalizing factor will be a to the power of 2 by 3 plus ab to the power of 1 by 3 plus b to the power of 2 by 3 is called the rationalizing factor for this. If I multiply both, we are going to get in the form of a plus b, I am getting it. In the same manner, if I multiply this and this, I am getting it as a minus b. Therefore, I can say that a for a to the power of 1 by 3 and b to the power of 1 by 3, rationalizing factor is a to the power of 2 by 3 minus ab to the power of 1 by 3 plus b to the power of 2 by 3. For a to the power of 1 by 3 minus b to the power of 1 by 3, rationalizing factor is a to the power of 2 by 3 plus ab to the power of 1 by 3 plus b to the power of 2 by 3 is the rationalizing factor. Now, based on this, we are going to discuss certain problems over this. Rationalize the denominator 1 by 7 plus 4 root 3 plus 1 by 2 plus root 5. Now, to rationalize the denominator, I have to multiply both numerator and denominator with 7 minus 4 root 3 divided by 7 plus 4 root 3 into 7 minus 4 root 3 plus 2 minus root 5 divided by 2 plus root 5 into 2 minus root 5. Now, here you can write like this. 7 minus 4 root 3 divided by a plus b into a minus b. That is a square minus b square. The formula which is a plus b into a minus b is equal to a square minus b square. In the same manner, 7 sevens of 49 minus 4 fours of 16. Therefore, 16 into 3, that is equal to 48, plus 2 minus root 5 divided by 2 twos of 4 minus 5, which you can write in the form of 7 minus 4 root 3 divided by 1, because of 49 minus 48, 1, minus 2 minus root 5 by 1, because minus 1 I am getting it, I am cancelling with plus, so that I am able to get minus. This you can write as 7 minus 4 root 3 minus 2 plus root 5, which you can call it as 7 minus 2 is 5 minus 4 root 3 plus root 5 is the answer for this problem. Now, here the question arises is, when I am multiplying the two surds, if the powers are same, whether it is to be added or whether it is to be divided or whether it is to be subtracted, this question arises. Generally, for this, there is one simple concept has been developed as theory of indices. Theory of indices basically speaks about if A is any non-negative real number, then a to the power of m may be any integer, either a positive or negative integer. If I multiply with the same number, a to the power of n, then I can write it as a to the power of m plus n, I can write it. But here the problem is, a should not be equal to 0 and m should not be equal to 0. If both are 0, we are going to get 0 to the power of 0, which we are calling it as indeterminate form. Indeterminate form. Now, in the same manner here, we can take like this. A to the power of m into a to the power of minus n, we can take like this. This is equal to a to the power of m minus n. This when m is going to be greater than n. Suppose in case of a to the power of m by a to the power of n, in this case we can write 1 by a to the power of n minus m, where n should be greater than m. Now, if I want to say that a to the power of m by a to the power of n is equal to 1 only when m is equal to n. In the same manner, we can think in this way. Now, if I take like this, 1 by a to the power of m, if I take it, this I can write in the form of a to the power of minus m, I can write it. A to the power of p by q can be expressed it as a to the power of p whole to the power of 1 by q, I can express it. Therefore, in this way, I can define what is going to be the theory of indices. These concepts are going to be very much useful when we are doing certain problems related to the irrational numbers. Suppose I have like this. 5 to the power of 1 by 7 is there. I can write in the form of 7th root of 5, I can write it. This is called 7th degree surd, which I can call it as. The same manner, if I take like this, 142 whole to the power of 1 by 2 is there. Now, this I can express in this way. This is nothing but a square root of 142, I can write it. But if any such possibility is there for factorization, we can do that one. That is 2 7, this you can write like this. 2 7s are 14 into 2 1s are 2 into 2 also I can write it. This I can express in the form of root 71 into root 2 also I can express it. That is a product of two surds which I can express in the form. In the same manner, suppose if I take like this, 5 to the power of 2 by 5 is there. I can write like this. 5 square whole to the power of 1 by 5 I can write it. 5 square is 25. 25 to the power of 1 by 5. This I can write in the form of fifth root of 25 I can write it. This is called fifth order surd, which we are calling it as. In the same manner, if I want to simplify, suppose if I want to simplify root 11 minus root 7, this is one problem, into root 7 plus root 11 plus root 7 if I want to simplify this. This is of the form a minus b, this is of the form a plus b. You can say that a plus b into a minus b will be a square minus b square, which is equal to 11 minus 7, which is equal to 4. Therefore, if I multiply root 11 minus root 7 with root 11 plus root 7, since they are conjugate, we are getting it as a real quantity, I am getting it. Therefore, earlier we have studied that this is the conjugate of root 11 the conjugate of root a minus root b conjugate, we have studied it as root a plus root b. The conjugate purpose is, if I multiply equivalent and opposite sign of the same surd, we will get it as a real number. Now, for example, if I take like this, root 6 divided by root 3 minus root 2 is there. If I want to simplify this, the conjugate of root 3 minus root 2 is root 3 plus root 2. Therefore, this I can write as root 6 into root 3 plus root 2 divided by, you can take it as root 3 minus root 2 into root 3 plus root 2, which you can write in the form of root 6 into root 3 is root 18, plus this you can write as root 12 divided by 3 minus 2, that is 1. This I can write in the form of 9 into 2, I can write it, plus this I can write as 4 into 2, 4 into 3 I can express it. Square root of 9 is 3 root 2, plus square root of 4, 2. Therefore, this I can write in the form of root 6 by root 3 minus root 2 can be written as 3 root 2 plus 2 root 3, I can express it. The same manner, suppose if I take 1 by root 7. Now, this is one problem. Multiply numerator and denominator with root 7. We are going to get root 7 whole divided by root 7 into root 7, which is equal to root 7 divided by 7. Therefore, in this way I can simplify the problem. Now, root 10 minus root 15 divided by 2 root 2. It is given that root 2 equal to 1.414, root 3 equal to 1.732. Now, I want to find out the value of this one if these are the given things. Now, you can write like this. Root 10 can be written as root 5 into root 2, root 5 into root 2 I can write it. In the same manner, root 15 can be written as root 5 into root 3 I can write it. Now, the logic is like this. Now, if I take like this, root 5 into root 2 minus root 5 into root 3 divided by 2 root 2. Now, this you can take out root 5 common factor, root 2 minus root 3 divided by 2 root 2. Multiply numerator and denominator with root 2. So that we are going to get root 10 into root 2 minus root 3 divided by, this you can write it in the form of 2 to the 4. Because of root 2 into root 2 is, root 10 can be written as root 5 into, you can take it as a 1 root 2, 1.414 into 1.414 minus 1.732 divided by 4. Approximately, we are going to get like this. Root 5 into 4 if I divide with 0.4 3 is 12, 21, 4 5 is again 4, okay, 4 5 is 20, again 4 3 is 12, again 12 means 20, 4 5 is, therefore 0.3535 into 1.414 minus 1.732, approximately 1.732, 1.414. This is equal to 8. Therefore, this is equal to 2 minus 1 is 1. Therefore, here we are going to get a 6 minus 4 is 2. Therefore, minus 0.218 I am getting it. if you but we have to take the root 5 value into the consideration. Root 5 value is equal to 2.245 something, we are going to get it. Therefore, if I multiply this with this number, we will get the desired negative number, we are going to get it. Simplify with the number 64 to the power of 1 by 6, I want to simplify. How to simplify this one? Generally, we know that 2 to the power of 1 is 2, 2 square is 4, 2 cube is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is equal to 64. So that we are able to get 2 to the power of 6 whole to the power of 1 by 6, which is equal to 2 we are getting. Therefore, ultimately the value of 64 to the power of 1 by 6 is 2. The same manner if you have like this, 625 whole to the power of 1 by 4 is there. 625 generally we can express like this. 5 to the power of 1 is 5. 5 square is 25, 5 cube is equal to 125, 5 to the power of 4 is equal to, this is 625. Now, this you can express in the form of 5 to the power of 4 whole to the power of 1 by 4, 4 cancel, the answer is 5. Now, we want to find out the value of, 4th root 81 minus 8 into cube root of 343 plus 15 into 5th root of 32. I want to find out this value. Plus, you can take out like this, 225 also I can take it, no problem. Now, the logic is like this. 81 is having 3 to the power of 4 is 81. Therefore, this you can write 3 to the power of 4 whole to the power of 1 by 4 minus 8 into 343. Suppose if I take like this, 3 to the power of 1 is 3, 3 square is 9, 3 cube is 27, 3 to the power of 4 is 81, 3 to the power of 5 is equal to 243. But the problem is 3, it is not going to, 3 to the power of 6, you will get 729, we are going to get it. But instead of doing so, if I take like this, 7, if I take it, 7 square is equal to 49, 7 cube is equal to 7 9s is 63, 7 4s is 28, 343. Therefore, here we are getting it as 8 into 7 cube whole to the power of 1 by 3 plus 15 into, just now we have seen 2 to the power of 5 is 32. Therefore, this will be 2 plus 15, 15 into 15, 15 5 is 75, 15 7 is 225. Therefore, this is the square root of 225 is 15. Now, you can cancel this one. Therefore, 3 minus 8 7s are 56 plus 30 plus 15. Therefore, 30 plus 15 is 45. 45 plus 3, 48. 48 minus 56 is equal to minus 8, I am getting it. Therefore, ultimate answer is minus 8. Suppose if I take a number like this, root 3 plus root 2 divided by root 3 minus root 2 equal to a plus b. If I have a plus b root 6 is there, I want to find out what is a and b is going to be. So, it is better to rationalize the denominator. If you rationalize the denominator, we are going to get like this. Root 3 plus root 2 into root 3 minus root 2 divided by 3 minus 2 is 1. Therefore, this is equal to 3 minus 2. But the problem is, I have to multiply both numerator and denominator with root 3 plus root 2. So that it will be root 3 plus root 2. Therefore, it will be root 3 plus root 2 whole square. 3 plus 2 plus 2 root 6 I am getting. Therefore, 3 plus 2 is 5 plus 2 root 6. Comparing a plus b root 6 with 5 plus 2 root 6, a equal to 5 and b equal to 2, we are getting it. Therefore, we can say that root 3 plus root 2 by root 3 minus root 2, if we rationalize it, we are going to get in the form of 3 plus 2 plus 2 root 6, then comparing a equal to 5 and b equal to 2. Suppose in case of, if I have like this, root 5 plus root 3 divided by 2 root 2 minus, if I have like this, so 2 root 5 minus 3 root 3 is there. I want to, this is equal to a minus b root 15 is that. I want to find out what is going to be the a and b values. Now, rationalize the denominator. To rationalize the denominator, I have to multiply both numerator and denominator with 2 root 5 plus 3 root 3. Then, root 5 plus root 3 into 2 root 5 plus 3 root 3 whole divided by 2 root 5 minus 3 root 3 into 2 root 5 plus 3 root 3, which is equal to root 5 into root 5 is 5, 5 to the 10, plus root 5 into root 3, root 15, therefore this is 3 root 15, plus again this is 2 root 15, plus root 3 into root 3, 3, 3 3 is a 9, divided by, this is 4 5 is a 20, minus 3 3 is a 9, 9 3 is a 27. Therefore, here we are going to get like this. Here we can write like this, 10 plus 9, 19, plus, because the same like surds can be added, therefore 2 plus 3, 5, 5 root 15 divided by minus 7, because 2 2s are 4, 4 5s are 20, 3 3s are 9, 9 3s are 27, I am getting it, therefore minus 7. This entire thing you can write as minus 19 by 7 minus 5 root 15 divided by 7. Therefore, if you compare a and b, we are going to get a equal to minus 19 by 7 and b equal to, we can call it as 5 by 7. So, in this way we can find out what are the unknown values we can find out, and then we can find out this. The extension of this real number system, you are going to study various operations on real number system, that is closure law, associative property, and then identity, and commutative property. All these properties are going to be useful in your life for Boolean algebra, which as on today we are using in computer sciences. Therefore, real number systems is one of the important essential part of our life.